Hi everyone. I just wanted to do a little intro for this vid because it's not my normal MO for this channel. So some of you might know that I used to have a 3D graphics related channel that I abandoned, I'd say like a year ago. Mostly just because it's a dead product and there's only a few hundred people using it at this point, and it's not really worth it for me to maintain the channel or make tutorials for it because there's really nobody using it. But occasionally I do get questions of people asking questions about how to do something, or people wanting to see one of my old vids, and I'm just going to put that content on this channel, and I'm going to put it in a playlist called 3D graphics, so it's easy to avoid if people don't want to be bothered with it. But it just gives me an easy way to keep everything in one spot, because I'm going to keep this as my main channel, and I'm just going to use this is going to be my only social media presence. So that's why I'm going to eventually delete the other two channels that I have. But I just wanted to let you know, say you weren't like, what the F is this? But so I mean, if just to give a brief intro of what this tutorial is about, is what a lot of times in 3D graphics you want to evenly distribute points over a sphere. And there's a couple ways to approximate it, but one of the easiest ways is using a Fibonacci lattice. And what that is there's this guy right here. His real name was Leonardo Bigola Pisano, but for some reason they changed his name on him to Fibonacci. And he didn't invent it, but he found this. He was one of the people to find this sequence where, if you look here, you can see what it is pretty much. If each number is the sum of the two previous numbers, and that's, you can see that here. Each number is the sum of each two previous numbers, and you can create if you use squares to build it, like you can see right here. You can create a spiral with it, and that's pretty much the concept of how you wrap points around the sphere using Fibonacci lattice. What happens is what you use this golden ratio, which is phi, and which is 1.161. It's an irrational number, like pi is. It just goes on forever. And I think one of the easiest ways to visualize what's going on here is that if you take larger and larger numbers of the Fibonacci sequence, so if you take these numbers and you go real high with them, what you get if you divide one by the previous one is it gets closer and closer and closer to the golden ratio, the closer you get to infinity, which this will never end. So I feel like it's a good way of thinking about it. But one way that you could do it algebraically is this square root of 5 divided by 2. And but I just wanted to give people a little bit of an intro on what's actually being done. So we're just going to use this ratio here to pretty much create a spiral that wraps around the sphere. And you can see it here. This is the code right here that I'm going to use. But I'm not going to use programming. I'm going to do it with nodes. But this is pretty much what I'm going to follow to do it. And I just also want to say, anybody that's watching this that doesn't know anything about 3D graphics, but you think you may want to dabble in it a little bit, there is Blender right here, which is free, fully featured digital content creation application. It's really more than you could ever ask for free. And it's pretty much why the software that I used to use is no longer relevant, which is fine. But if any, it's totally free. So what I'm showing you here can easily be done in any 3D software. It can be replicated in any modern 3D software. So don't really try and think of the concepts of what I'm doing, not so much the software that I'm using, because it really can be replicated in any modern 3D software. Just the buttons might be in a little bit of different place. That's the only difference. So that's all I wanted to say. So let me just get started on the tutorial. Okay, so the first thing we need is an array of points. And the way I'm going to do this, I'm just going to clone a point on the z-axis. And I'm doing meter apart, and we'll do 1,000 points. So that's going to be the max number of points we'll have in our on our sphere. Just going to name it fib points. So we'll save that. So that's all we really need for this part. So I'm just going to go to layout. I'm going to load those points. So those points is just gives us an indexable array basically. So I'm just fixing the grid size, getting everything out of the way, putting it on wireframe or vertices so we could see them. So now all we got to do is get these to go on a sphere. And the way we're going to do that now, I'm going to do it in the displacement texture here. I'm going to use node texture, but you could do this in node deformations. The reason I'm doing it this way is because I may go a bit further with it where I want to do more deformations after the fact. So I'm just going to do it in here with node texture. So the first thing we're going to get is a spot info. And then we're going to get a vector subtract, or we'll get a split vector because we got to get the z coordinate. And the other thing we have to do is we have to take into account that all our points aren't at the origin. So we're going to get a vector subtract, and we're going to get a make vector. And then we're just going to subtract our point position from, well, right now it's going to be 0, 0, 0. So you'll see that they'll all jump back to the origin. So then everything we do will be in between. We'll pump into that make vector node. So the first thing we're going to do is we're going to floor that z. And if we look at this code here, you can see the first thing we need, we have our 1,000 samples and we have our indexable array. So the next thing we need is this variable called phi, which is basically just what we need is the golden ratio in radians. So the way we can do that is we're going to get AS tools math pi, and we're going to get a multiply node, and we're going to get a subtract, or we get AS tools square root, and we also need a subtract. So the way we can get the phi in radians is we could get 3 minus the square root of 5 multiplied by pi. So that's what I'm doing here. I'm just taking the square root of phi, subtracting it from 3, and then I'm just going to multiply that by pi. And that'll give me phi in radians basically. So that's all we need for that. So the next thing we need to worry about here is the loop basically, which is where we'll use our index, our indexed points. So the first thing we're going to deal with is the y coordinate. So the way we get the y is we need to get, I'm going to, let's see, what do I get first? Divide, and we're going to divide by 999. That's, I'm going to animate that eventually, but for now that's the samples minus 1. You'll see that in the code if you look at it. And we're going to multiply that by the index. So you can see right there we got I divided by samples minus 1. And that's what that's giving us right there. I divided by samples minus 1. And the next thing we need to do is we need to do 1 minus. See, this 1 minus is the last order of operations, so keep that in mind. So what we need to do first is multiply that by 2. And then we could get a math scalar subtract, and we could do 1 minus that. So we'll do 1 and then subtract that from 1. and that will give us the y coordinates. So you'll see if we go into the y, it'll just push all our points where they're supposed to be on the y. But we still need to deal with the x and the z. And the way we deal with that is with sine and cosine. So, well, before we get to that, we need this thing called radius. It's another variable here, and that's square root of 1 minus y times y. So we'll copy this square root, and we're going to need to multiply, and we're going to do y times y, and then we'll do 1 minus that, and then we'll go into our square root. So that gives us the variable called radius. And then the next part we have to deal with is this theta, which is just phi times the index. So we'll just take that variable we created, phi, which is in radians. We'll multiply that by the index, which is this floor right here. And that's that. So then the next thing we need the cosine and sine of theta multiplied by the radius. So we're just going to get trigonometry, cosine, trigonometry, sine, and all we're going to do is just, we're going to cosine and sine of theta, which was what we just created in that last step, which was I times phi. And then all we're going to do is multiply that by the radius for each one, which was this variable here that we created. And that's pretty much it. So then the cosine goes into the x, and the sine goes into the z. And you'll see that that'll give us the Fibonacci distribution over the sphere. So now I am going to do a little bit just to animate this. First I'll tidy up these nodes a little bit. So it's not really too much more to animate it. There's a bunch of different ways you can animate it, but for what I did here, it's pretty simple. So the first thing we want to do is we want to animate them coming out from 0. So the way we can do that is we can just animate that divide. So instead of doing 1 minus, or the index minus, or the index divided by 1 minus the sample count, which is 199, we can just animate that from 0 to 199, in that divide there. So we'll just animate that from 0, which actually you would want to do, and I'm doing it over 300 frames, so it'll be 10 seconds. So it's going from 0 to 999 over 10 seconds. But you would actually not want to go to 0. It really won't make too much of a difference here, but later on you want to go from like 0.0001 to 99, just because you shouldn't really divide by 0. But it really doesn't make a difference here, but it will when I do the lines. And what else I'm doing here is I'm just multiplying that y divided by times -1, because it's not coming out from the right direction. So now it's coming out the way I want it, from the top to the bottom. So all I did was I just took y and then multiplied it by -1. So that gives us that part of the animation. Now I also want them to disappear too from the top to the bottom. So they're going to come out and then they're going to disappear once they come fully out. So the way I'm going to do that, I'm just going to add to should be from that floor that I'm adding from. I don't know if I fixed that or not. I don't think it'll matter too much. So on frame 500, I'm going to go from 999, or from zero, I'm subtracting here. So I'm going from negative 999, from 0 to negative 999, basically, coming out of that Z. And you'll see what that happens when I plug that in. And that's going from 500 to 800. So for 200 frames, it just stays there. So that's pretty much it.